basically pipe installed pyCLAD. We also installed PyTorch before. And when we have pyCLAD, we can do, I will just try to clear cells. If I can. Okay.
Maybe run in run menu.
Run menu.
Oh no.
No. Okay, no worries. So here we have importing pyCLAD, which is simply import, as we all know. And when we start with dataset creation, it's the same example that I've shown before. So I will just show that it works, and I will go through it once again. So we're creating concepts, and then we're creating dataset. Then the next step is defining model. So we're using pyOD adapters and one class SVM adapter. Very, very simple. We define cumulative strategy, so the one that stores all the data encountered so far. We defined callbacks, and then we do scenario execution. It's very fast because the data is very, very small. But what happens here, we get info in logs that we start training on concept 1, on batch 0. Then we do evaluation on all concepts. And then we start training on concept 2 and concept 3, evaluating all concepts. Okay, and here, this is the part that wasn't basically shown before. So we defined callbacks. Here we defined metric callback and time callback, and we can take a look on results from this callback. So the results are, can be accessed by info method, and we can see here that we got info about metrics, continual average, backward transfer, forward transfer, and we got this metrics metric matrix. Then in time callback info, we got info about train time and eval time for each concept and the whole thing. We can easily store the results in JSON. So right now I could just read this output JSON file and we could proceed with it. And here we have a simple, we have example for UNSW dataset. And this is like the full example with real dataset and something more complex than one class SVM. So we have all imports, obviously. Then we set up logging, and then we start with defining dataset. Actually, I should have done it before. Sorry for that. So we define dataset, UNSW dataset. It can be downloaded automatically from Hugging Face, so this happens under the hood. We define model, which is pyOD adapter for variational autoencoder. Here we define replay buffer, adaptive balance replay buffer, which means that for every concept encountered, there is a separate buffer that is balanced. So for if we have max size 1000, which means that we can store at most 1000 samples in this replay buffer, it means that if we have 10 concepts, every concept will have 100 data samples stored. And then we define callbacks. In this case, we also involved memory usage callback, which provides information about the memory use during the scenario. And we are using concept-aware scenario. So if I run it, we'll see training in real life. It can take a while, so I will just tell you that in the following part, there is an example for you that you can implement on your own. So there are all like basic things here. There are imports. There's also step-by-step information how to implement using the scenario. And if you implement it, you will be able to compare two different strategies. So we can compare, for example, a replay with naive strategy, or you can implement your own strategy here. And then we also invite everyone to extend pyCLAD library. It's available on GitHub. There is a contributing guide. So if you implement something using pyCLAD, we'll be happy to help you with pull requests and extending the library.